So the last method is the Nodal method. The advantage of this method is that it produces the least amount of equations necessary to solve. The other part of it that people don't like is that it requires fractions, and everybody kind of doesn't like dealing with those. But it is a good method to know. So let's mark our currents like we had before. And so we've got these were how I had before. So we had I1 and I2 was coming this direction. I3 from right to left. I4 and I5. Okay. Now the basic concept, there's really only two nodes. You use every node except for the ground node. And what I'm going to do is write Kirchoff's current law for each of these equations. So for node V3, I have that I3 plus I5, those are into the node, minus I2 equals 0 amps. And now, and I forgot to put in my polarities. I very much apologize. I'm going to need that. R1 is positive on the left, minus on the right. R2 is positive on the right, negative on the left. R3 is positive on the right, negative on the left. R4 is positive on the bottom, negative on the top. And R5, positive on the bottom, negative on the top. And now I want to write my currents in terms of my potentials. So V3 and V4 are what we're going to want to solve for. So these need to be in those terms. So I3, what we do is we take the tail, the potential at the tail, and subtract the potential at the tip and divide by the resistance. So in this case, I3, the tail goes to V2, the tip goes to V3, and the resistor is R3 plus, now for I5, the tail is at 0 volts or ground, minus tip is at V3 over the resistance R5 plus, minus and the tail is at V3, the tip is at V4, and the resistor is R2. That's equal to 0 amps. Now for node 4, we have I1 plus I2 plus I4 equals 0 amps. So I1 is going to be, the tail is at 12 volts, minus the tip is at V4 over R1 plus, for I2, the tail is at V3 minus V4, because V4 is at the tip, over R2, and we have plus, the tail is at 0 volts, the tip is at V4, and that's going to be divided by the resistor R4, and that's equal to 0 amps. And now you can solve for V3 and V4. And once you get V3 and V4, then you're just going to put it back into these relationships. I3 is going to be equal to V2 minus V3 over R3. Well, you know V2. You'll calculate V3 and R3 you have, so that's going to be equal to I3. This term is going to be equal to I5, and this term is going to be equal to I2. And the same with the node 4 equation. So you can solve this very quickly, very easily, and get all the values that you need from the nodal method. And as I said, it requires the least number of equations.